Alright, students from M1EP. Today you're going to be learning about conserving fossil fuels and renewable and alternative energy. So we have quite a few different types of energy sources. The ones on the right are non-renewable. We have nuclear power and three fossil fuels: oil, coal, and natural gas. And on the left, there'll be five that we'll be studying. These are the five that are included in your book. I know that there's others, but we're not going to be talking about them. What I want you to know about is biomass, hydro power, wave power, wind power, and solar power. So just a little bit first about differences and definitions of renewable energy and non-renewable energy. So renewable energy resources will not run out. They can be replaced naturally before 100 years. So we talk a lot about within our lifetimes. And the most common types that we have today are wind power, water power, solar power, and biomass. And non-renewable energy resources, well, they cannot be replaced before 100 years. And these are fossil fuels: coal, oil, and gas. Remember, anything in blue you want to copy down into your notebooks, you can pause this video at any time. Okay? Remember, copy this down. Alright, so basically the first thing I want to talk about is how a turbine generator works. We have two main parts. The turbine is their blades, kind of like a fan, and kinetic energy from steam or wind or wave action powers these blades. The blades are going to be transferring the kinetic energy coming into kinetic energy of the blades spinning. And so the blades are connected on a shaft or a rod, which is connected to a generator. And the generator has a bunch of coiled copper wires and magnets inside, and what they do is they create an electric current, and this electric current is making electricity. So a generator is taking kinetic energy and it's transferring it into electrical energy, electricity. So this slide I'm going to show you what's happening in a coal-fired power plant. This could also be natural gas or oil. And in the chamber, the container on the left, there's a fuel source: coal, oil, natural gas. And it is burned, combusted, and this heat is going to boil water. It turns to steam, and then it runs through a bunch of pipes. And this steam is under high pressure. And so the kinetic energy from the steam, the moving energy of the steam, will spin the blades of the turbine. Again, it's connected to the shaft, a rod, which connects to the generator, and the generator makes electricity. Now, this electricity comes out of the power plant and goes through something called a transformer, where that electricity can be, the voltage can be stepped up, or the voltage can be stepped down. It goes to power lines or power mains, and that is what goes off to your houses. Alright, so we had talked about how fossil fuels cannot be replaced within 100 years. It takes millions of years to make fossil fuels. So what we need to do is make them last longer. And so our vocabulary word for this is conserve. We need to conserve energy, we need to conserve fossil fuels, and this is using them carefully so they last longer. So there's a plan to conserve. A plan to conserve includes different areas where we can help to make fossil fuels last longer. One of them is planting more trees. We're cutting down a lot of trees, and we're putting a lot of carbon dioxide into the atmosphere whenever we burn fossil fuels. So plants will actually take those into their the material when photosynthesis occurs. We should also try to drive cars less. we don't burn as much fossil fuels. The 3 R's: reduce, reuse, and recycle. Okay. Using less electricity, and stop using fossil fuels. So we should try to improve technologies and build more power plants that are using the power from the wind, the waves, and solar energy and biofuels as well. So we have 5 types of renewable energy that we're going to talk about. These are the 5 that are covered in your book. They're alternative energy, and alternative energy is basically something that's going to replace fossil fuels. Our country and all throughout the world is dependent on fossil fuels right now. We depend on them for our survival and our way of life. And we need to just think about how we're going to create energy in the future, because fossil fuels will be gone someday. All of the energy from renewable energy originally comes from the sun. So number 1 is biomass. This is a plant or animal material that is a store of chemical energy, and it can be burned as a fuel. We have 3 that are big, that are the 3 most common. This is wood, so chopping down trees and burning the wood. You can see a brick oven, and there's a pizza. So just burning wood creates heat and light, and we can cook food that way. And we can also create electricity that way through a power plant with a turbine and a generator. Pictures in the bottom are dung, animal dung. So that is poop from animals. It can be dried out, mixed with straw, and burned to heat a home or to cook food. And another very popular one is methane. And methane is a gas. It's a combustible gas, which means it can be burned. The chemical symbol for methane is CH4. So up at the top, there's a picture of a cow. And cows have different stomachs, and those stomachs, they have a bacteria which can survive without oxygen. Something that can survive, bacteria that can survive without oxygen is called anaerobic, just to throw another word at you. And one of their products is a gas methane. And so something has been created from this called a biogas generator. And there's the picture on the bottom is showing a cycle, and grass goes into the cow, and manure, animal waste, comes out, and it goes into a biogas generator, which is a container underground, and there is anaerobic bacteria that break down, they decompose the animal waste. And like I said, one of the products they produce is methane gas, and that methane gas can be pumped into the house to keep the house warm or as a cooking fuel for stoves. So another technology and renewable as well. Okay, 2A. I'm talking about what a solar furnace is, and then solar power. So a solar furnace, you can see a big picture there. It's a lot of mirrors, and they direct sunlight at a big container at the top of this tower. And in that container there's water, and the water is boiled and turned to steam. And this steam will spin turbines, which are connected to generators, a power plant. So creating electricity again. And here is a solar cell. Solar cells, they can directly transfer radiant energy, sunlight, into electrical energy. And that's because inside of a solar cell you have silicon. And silicon is a semiconductor. Basically it behaves like a metal, and it also behaves like a non-metal. And there's 2 sheets of silicon that are sandwiched together. And when the photons, the particles of light, hit the top sheet, they excite the electrons in the silicon, and this causes them, some of the electrons pop off and go to what's called a higher energy level. And these electrons, being negatively charged, push each other away, and this is called their electron flow and creates electrical current, and that can go off to power light bulbs or other kinds of components that you have in your house. Okay, 3, wind power. So very simple definitions here. The energy in the wind comes from the sun. Okay, you will see a picture on the left, and that's a wind turbine farm that's out in the ocean, getting a very good current, wind current coming on shore. And then there's a diagram on the right, and I want you to take a look at the diagram on the right and try and find the generator. It's located towards the end of the wind turbine. And just to remember what generators do, please remember, hopefully you do. Okay, taking that kinetic energy and turning it into electrical energy, transferring it into electrical energy. And in this diagram, I also want you to try and look for the turbines. It's not the same kind of a turbine that you saw in the previous pictures, but it's still blades. And the blades are on the outside, and they are powered by the kinetic energy of the wind. Okay, 4, wave energy. This has become more and more popular. Not necessarily popular, but there's more wave energy power plants that are being built. So it's energy from the waves, which originally comes from the sun, and those waves go into a power plant. You can take a look at the diagram where the waves will go in and they will actually compress air that is inside the power plant, and this will push the blades of a turbine, and again creating electricity in a generator. There's another picture here which it's showing ocean currents that are, so it's another wind turbine, but it's set up on the ocean floor. And there's more of these that are being, it's more of a new technology that's in development right now. Okay, another picture of wave energy. So this is out to sea. This one was along the shoreline, but this one is out to sea. And you can see coming, the end of the diagram, the picture shows that the waves come in on an open end, and they will compress air towards the opposite side of the machine. And this compressed air, air under pressure, is going to go up and out, and when it goes up and out of the machine, there's a turbine and a generator. You can see the red arrow pointing to a very small turbo generator, and that will create electricity. Same process as before. And the last type of renewable energy we want to talk about today is hydroelectric power. So this is the picture shows a dam which will hold back water in a reservoir, and then it's released through the bottom, out through the bottom. So the water behind the dam is creating tremendous pressure, a lot of pressure. And when the water is released, the water spins the turbine and the generator, creating electricity. So the positive and negative, there's been a lot of argument for many, many years about this. They can make a lot of electricity, and so they're a very good type of power plant to build, just because they have the potential, the ability to produce a lot of energy. But the downside, the negative to this, is that they destroy a lot of ecosystems, because when you create a dam, you have to flood a valley. So this big dam, the big wall, is all cement and metal and steel. And behind it, there was a valley, and there were a lot of animals and plants, trees, ecosystems that were there that were destroyed, and also there might have been people living in the valley, and people would be displaced. They would be moved out of the valley and would have to give up their homes in the process. So positive and negative to this, and moving forward, is this a good type of renewable energy? Well, there's people that are going to say yes, and there's going to be people that are going to say no. And there's some proposal right now, which is the Mekong River Dam project. And so this is running through 3 countries. It's running through Laos and Vietnam, and also through Cambodia and Thailand. Sorry, 4 countries. And you can see that there are many dams that are proposed, that are in the process of being built, or they're being proposed, where it could be a place where a dam is built. Okay. And this will be discussed a lot in the future if other forms of alternative energy are not found. How are these countries going to create enough electricity for growing populations? And the countries are getting bigger, and more infrastructure is being built, like roads. And so to power the country, what are we going to do? And that'll be up to you guys in the future to come up with some of these solutions. And I want you to be thinking about different types of alternative energy. We'll be discussing this in class. So I will see you next time.